In the previous lesson, we looked at arithmetic sequences and series. Remember, sequence is just the list of numbers. Series is when you add those up by putting plus signs in between them. Well, arithmetic series are where you added on the same number each time to move from term to term. There are other patterns. Another very common one is called a geometric sequence. So here's what I'd like you to do. Take a moment. I want you to continue each of those patterns and see if we can get the next few terms going. So see if you match me. My next number, I got 324. And then after that, I'm going to get 972. And then the pattern would continue on. This time, instead of adding the same number each time, you're multiplying by the same number each time. Times 3, times 3, times 3, times 3, and on down the line. Let's now take a look down here. I'd like you to do the same thing. Okay, so I can see here that the size of my numbers is getting smaller. So negative 48, negative 24, negative 12, negative 6. The next numbers I'm getting are negative 3, negative 3 over 2, negative 3 over 4, and then continuing that on and on. So in terms of size, these are getting pretty small, very close to 0. Two ways to think about it. You can think about it as a division by 2. But I need you to know that dividing by 2 is the same thing as multiplying by the reciprocal of 2, multiplying by 1/2. So numbers get larger if you multiply by a number bigger than 1. Your terms in the sequence get smaller if you multiply by a number less than 1. Just so you know, you're allowed to multiply by negatives as well. What matters for a geometric sequence or series is that you're multiplying by the same number each and every time. Big, small, positive, or negative. So here we go. A geometric sequence consists of terms with a repeated common ratio. That's the number you multiply by. And those are denoted by R. So they typically come in 2 formulas, depending whether you're basing on the first term, which is very often easiest, or if you are basing on the 0th term, which often gives you some useful insight into the structure of the sequence. Let's just take a look at an example. We'll write it both in terms of its first term basis and its 0th term basis. So consider this list. Let's have it be, how about 5, and then 10, and then 20. We'll keep it nice and simple. And on and on. We need to note here that our common ratio is 2. We're multiplying by 2 each time. Then let's go ahead and see what our sequence looks like. If I'm writing it in this first format, it's just the first term, which is 5, times 2 to the power of n minus 1. 2 because our common ratio is 2. And here's the nice thing. You can now find any term in the sequence just by putting that number, the number of the term, in for the n. So for example, we know the 4th term is supposed to be 40. Well, put a 4 in here. 4 minus 1 is 3. 2 to the 3rd power is 8. 8 times 5 is 40. Look at how much fun that was. No reason, though, that you can't also do a 0th term. Now, here's the thing. There's no 0th term listed. So you kind of have to imagine what it would look like if you went backwards. Oops, I want to just an n here. If you went backwards one more step. So notice that each time you move left, you're doing the reverse of multiplying by 2. You're actually dividing by 2. So 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. And 5 divided by 2 is 2.5. It's important to know that these two are the same thing. They will give you the same results. Let's see how that works. Again, for the 4th term, put a 4 in for the n. We know the answer should be 40. So if I take 5/2 times 2 to the power of 4, look at that, we end up in the same spot. Which is better? Depends what you're using it for. Sometimes this is easiest. You're going to see a lot of this in the lesson here. Sometimes this is easiest. Typically, if you're looking at like modeling an exponential graph, this is an easier way to go. But know them both. A geometric series is what happens when you take the numbers in a geometric sequence and add them up. The good news is there is a shortcut. The bad news is I'm not going to let you know what that shortcut is yet. We'll take a look at that in the next part of the lesson.